At first glance, it might seem that what you see on the screen is just an ordinary cuboid or parallelepiped, which may not seem to be anything special. But, in fact, before you is the entire universe. Our universe. I had to throw away all of my ideas about space-time and break all my normal thought patterns in order to understand why our universe is enclosed in this cuboid. Which means that for the next 10 minutes, you will also have to turn your entire way of thinking upside down. So, why does the universe have such a strange shape? What exactly is a block universe? And why has your tomorrow, the day after tomorrow, and indeed the whole future already happened? And why are time travels hundreds of years ahead real? According to the theory of the block universe, the past, future, and present exist simultaneously. We can best explain this concept with the cuboid shape. The cuboid's height and width represent 3 spatial dimensions, and length is a temporal dimension. At one edge of the cuboid is the Big Bang, that is, the beginning of space-time. And on the second edge is the death of the universe. Every event that ever happened, be it your birthday, or, for example, the extinction of dinosaurs 65 million years ago, is located at a corresponding point in the cube. Thus, a place in space and a place in time are one and the same. For these reasons, time travel is theoretically possible. In this case, probably many of us would like to go back in time and change something in the past, but according to the block universe theory, this is unrealistic, and here's why. All events of the past, present, and future have already happened and are happening now. If you were, for example, sometime in the future to travel back to try and prevent the Second World War, then you wouldn't be able to do this because the future in which you found a way to travel to the past has already happened. But since the Second World War also already pre-existed, it means that you couldn't change anything. If you do manage to go back in time, you can of course communicate with people and do whatever you want, but it won't change anything. All events and the course of time will remain the same. This is because in the model of the block universe, time doesn't change, it doesn't go anywhere, it stands still. But we, as many physicists believe, feel the passage of time forward thanks to the second law of thermodynamics. According to this law, any system tends towards entropy, which means the dissipation of energy, or more simply, disorder. The result is that any increase in entropy is precisely the passage of time into the future. Since there's no way back from disorder to order, for example, a broken egg cannot become whole again, so time also cannot go back to the past. However, the famous physicist James Maxwell would not agree with this. Back in 1867, he conducted a thought experiment refuting the irreversibility of entropy. So, the experiment goes as follows. Suppose we put gas in a closed vessel, divided in half by an impenetrable wall. A hole will be placed on the wall with a hypothetical device, the so-called Maxwell's demon, which will allow hot and fast molecules to move to the right and cold and slow ones to the left. This will prevent any energy exchange, and a closed system will move from chaos to order. That is, the level of entropy will decrease relative to the initial level, violating the second law of thermodynamics. So this thought experiment involving Maxwell's demon would have been strong proof that entropy, and therefore time, can be turned back, if not for one problem. For the functioning of the demon itself, a large amount of energy will be required, which will be dissipated, which means that the overall level of entropy will only increase. Consequently, lowering entropy and heading backwards in time will not work, at least not yet. However, traveling to the future is much easier. As I said, the direction of time into the future is related to the dissipation of energy. That is, with decay. The half-life of one of the smallest subatomic particles, muons, is approximately 2.2 microseconds. If you have, for example, 100 muons, after 2.2 microseconds, there will be 50 of them. Now let's change the conditions a bit and send a handful of 100 muons on a trip at 50% of light speed. While for motionless objects, 2.2 microseconds will have passed. For moving objects, the equivalent time is just 1.9 microseconds, and not just 50 muons will remain, but 55. More simply put, movement at 50% of the speed of light will allow you to find yourself in the future in a shorter amount of time and with less decay of the smallest particles. And the more the speed approaches the speed of light, the faster and further we'll be able to travel into the future. Only in this case, there is one snag, the so-called twin paradox, described by Paul Langevin back in 1911. So, imagine that you have an evil twin brother who wants to destroy the planet. In an attempt to stop him, you put him on a rocket moving at a speed of 90% of the speed of light, heading away from Earth. Let's say that for you, 9 years have passed. Meanwhile, for your brother, only 4 years will pass if he manages to turn the rocket around and return to Earth at the same speed. You will be 18 years old while your twin brother will be only 8 years old. However, here is the paradox itself. From the point of view of your twin, the Earth and you along with it also moved at 90% of the speed of light. So from his perspective, for you it took 4 years, and for him as long as 9 years. Thus, we have a time mismatch. A small matter at first glance, but because of this seemingly minor issue, for many, this casts doubt on Einstein's special theory of relativity, on which modern physics is largely based, including all our hopes of time travel. The fact is that according to this theory, any reference systems are equal in respect to time, which is not observed in our case of the twins presented here. Nevertheless, reference frames can be considered equal only if they're both at rest. Here, the evil twin experiences acceleration, while you are practically immobilized when compared with the speed of light. In this case, just based on acceleration alone, some unusual things will begin to happen. Suppose you and your twin were each given a mechanical watch to be able to check the time at regular intervals. After that, your brother traveled 2.67 light years from Earth and immediately back. In this case, while your evil twin is flying away from Earth, his watch will begin to tick faster than your watch on Earth. But everything will change dramatically after the U-turn. The sharper it is, the more time will slow down for the evil twin. Then, at the moment of approaching Earth, your brother will think that time on his home planet is moving much faster than in his rocket. Thus, a little over 2.5 years will pass for the twin to return home, and for you, 6 years. So, you get older much faster than your brother. It follows from this that the more the speed of objects approach the speed of light, the more their experience slows down compared with other objects that do not move at such a high rate of speed. In theory, this is all, of course, interesting, but I would like to test such assumptions in practice. Fortunately, scientists have already done this for us. True, mankind has not yet learned to fly at the speed of light, but the results of one experiment prove that the solution of the twin paradox that I described is correct. To do this, the researchers took a pair of identical, synchronously running atomic clocks, with ultra-precise mechanisms that have a margin of error of only 1 second every 100 million years. Scientists left one clock in place, while the other went on a journey in a supersonic airplane around the Earth. Upon its return, the researchers found that these most accurate clocks in the world began to diverge in their readings. The difference was very small because the speed of the aircraft doesn't reach the speed of light. Nevertheless, this experiment proves that travel into the future is possible. And if humanity learns to move at the speed of light, some of us will be able to jump over a century in several decades. As for travel to the past, there's another paradox that makes this impossible. But I know the solution to this, and in the next release, I'll share this knowledge with you. If you like my video, subscribe to the channel, click on the bell so you don't miss new releases, and give us a thumbs up. And share this video with your friends. It's more interesting discussing these fascinating topics together.